Hello, my name is Daniele Rosso, and first of all, I would like to thank the organizers of the conference for giving me the opportunity to give this brief presentation about my joint work with Jonas Hardwick about Grothendieck rings of towers of twisted generalized Weyl algebras. Twisted generalized Weyl algebras, called TGWAs for short. This is a family of algebras that are defined by generators and relations starting from certain parameters. So triple parameters R, sigma, and T, where R is a ring, usually a K algebra, so for example, a polynomial ring. Sigma is an n-tuple of commuting automorphisms of our base ring, and T is going to be an n-tuple of elements in the center of the ring. This is a very general family of algebras, and it includes a lot of examples of algebras that are interesting in representation theory. So, for example, Weyl algebras, as the name suggests, and also certain quotients of universal enveloping algebras. So, although TGWAs in general, they're not in any natural way, they're not half algebras or bialgebras, so they don't have a co-multiplication map. The new observation of this work is that if we take different TGWAs corresponding to different parameters t, so we fix R and sigma and we let t vary, then we can get a map which is sort of like a co-multiplication map that goes from the algebra corresponding to the parameter t times t prime into the tensor product of the algebra corresponding to t with another algebra corresponding to t prime. And notice that this tensor product is not over the field K. This tensor product is over the base ring R. Okay, then using this map, if we have modules for two different TGWAs, we can take the tensor product over R of those two modules and then restrict along this map delta, and that gives us naturally a new module for a different TGWA. Okay, so for example, we can start with two modules for the Weyl algebra, and we naturally get a structure of a USL2 module on the tensor product. So now this operation of taking a tensor product of two modules and obtaining a module for another TGWA gives us an operation on Grothendieck groups. So what we can do is that we can take the category of all what we work with weight modules. We take the category of weight modules for TGWAs. We take the Grothendieck group of that category, and then we take the sum of all the Grothendieck groups over all different possibilities of parameter t. This is why we call this this family of all the AT with variant t. We call this a tower of these TGWAs, and we get, so now this tensor product becomes an associative and commutative operation on the sum of all these Grothendieck groups. So we call this the Grothendieck ring corresponding to certain parameters R sigma, and with a certain multiplicatively closed set of all the t's. So then we have defined two new rings or two new algebras, one with Grothendieck group, one with the split Grothendieck groups, and then we can explicitly compute or describe what these rings are going to be in some specific cases. So when R is a polynomial ring in one variable, sigmas are translations, and we are in rank 1, we can describe explicitly the Grothendieck ring and the split Grothendieck ring. This is the case that relates exactly to the Weyl algebras and quotients of USL2. And then we can also do the rank 2 case explicitly, which has a little more involved work concerning the weight modules in this case, which comes from previous work of mine and of Jonas. Thanks for listening to me, and goodbye.